Thank you, Carmine. Dear participants, I am Markus Fiege, and I would like to give you an introduction into the Vehicle Data Protocol. Let me introduce the agenda for today. I will start with the motivation. Why do we need a new protocol? Then I will go deeper into the Vehicle Data Protocol and describe some details. At the end, I will present a software component for realizing a VDP solution, the VDP Communication Module Remote. Now, let's start with the motivation. Data collection wants to collect data inside the vehicle during normal operation at the customers. To be able to collect all required data, also smaller devices running with classic AUTOSAR must be enabled to participate at the data collection. This is where the VDP protocol comes into place. It wants to provide data collection for AUTOSAR classic ECUs and let them sending the data to the data collection core on an HPC. This standardization grants interoperability between different customers and solutions. VDP provides a standardized and lightweight in-vehicle protocol for data collection that can be used within serious vehicles. It provides different sampling and transmission modes that can be configured dynamically. VDP keeps the bus load at a minimum. That means it uses as less bytes as possible. It collects data locally with an easy-to-implement interface. In general, VDP decouples data sampling from transmission. The image shows some details of the data collection solution using VDP. Inside the vehicle, we have an HPC and a classic AUTOSAR ECU. Inside the HPC, the VDP consumer is connected to the data collection core. The VDP provider is connected to a remote data source. HPC and classic ECUs are connected through VDP consumer and VDP provider. And the user interacts through the cloud communication with the HPC inside the vehicle. The cloud sends the configuration to the HPC inside the vehicle. Then it's passed from the VDP consumer to the VDP provider on the classic AUTOSAR ECU. The VDP provider collects the data from the remote data source and sends it to the VDP consumer on the HPC. The data collection core sends it to the cloud, and there it's available for the user. Data collection may require different sampling modes depending on the type of data point. For example, the voltage of the battery may require cyclic sampling, while state transitions may be better sampled event-based. The VDP supports these different sampling modes, and they can be configured dynamically for different data points at runtime. Here we see an example with two data points. Data point 1 is configured to sample cyclically, and data point 2 samples event-based. The samples for data point 2 are fired in between the cyclic samples of the data point 1. All samples will be collected and transmitted on the bus according to the transmit trigger. Now, I will give you a deeper insight of the VDP protocol. Let me introduce some keywords first. The data point represents a collectible value. It is connected with a timestamp. The VDP slot ID is a unique dynamically assigned identifier that identifies the data point. The VDP Communication Module Remote is a component of a classic AUTOSAR ECU. It will collect the data points and send them to the HPC. The DCA remotes are components inside a classic AUTOSAR device that retrieves the data and passes it to the VDP CM remote. The VDP CM proxy is the counterpart of the VDP CM remote on the HPC that configures them and receives their collected data. Then we have some different kind of messages that are exchanged between VDP CM proxy and the VDP CM remote. Control messages are used to configure the VDP CM remotes. We have the control message add dynamic configuration to add a configuration and remove dynamic configuration to remove it. Then we have the activation message to activate the sampling and a trigger message to trigger a single sampling. Additional type of messages are the data message and the error message. The next slide will show a typical communication sequence. Here we have again the components VDP-CM remote and the DCA remote. The DCA remote will request data at the data source and then at the data point with add sample to the VDP-CM remote component. It will store it in a data message buffer with a header, a reference timestamp, VDP slot ID, the relative timestamp, and the data itself. This will happen several times, and at some point, the data message buffer is full. And the VDP-CM remote will send the data message to the HPC. Before the data sampling starts, we need to configure the data collection. First, we need a control message at dynamic configuration that configures which data points are required. It configures a potentially sampling frequency, that's the time between two samples. It may configure the persistence of settings and data and configure additional security if needed. It will also configure if the data is sampled immediately or not. The activation message will start the sampling, and the trigger message will request to get a data sample immediately. The VDP-CM remote will forward it to the DCA remote that will directly acquire the data point and add it with an add sample to the VDP-CM remote. Within the vehicle, the data collection is typically a low priority use case. It shall not inhibit other use cases or even functional safety relevant application. That results into the consequence that data might not be sampled by the DCA remote. The data might be lost because of a buffer overflow, or it might be lost because whole frames are lost due to the low priority. But that is okay, as long as we know that data samples have been lost. VDP provides mechanisms to report all these data losses to the cloud. The next slide will show the feature dynamic data length encoding. One feature to reduce the data load is the dynamic data length encoding DDLE. VDP makes heavy use of this encoding scheme. DDLE does not need a length field. It uses the most significant bit of every byte to indicate whether another byte follows or not. So here in the example, we see that the first byte has the first bit set. That means we will get a second byte. In the second byte, the MSB is not set. That means we will stop here. So we will have two bytes that will be combined into one value. This encoding scheme can reduce the amount of required bytes based on the values that have to be encoded. A value less than 128 requires 1 byte of data instead of 2 or 4 bytes if you use a length field. Additionally, the length can be extended in future versions without breaking backward compatibility. Now I will come to timestamps. Data collection requires timestamps to be able to set information into the correct chronological context and correlate the collected data. Therefore, every sample needs a timestamp attached. To compress timestamps, VDP uses an absolute reference timestamp in the data message and then combines relative timestamps and dynamic data length encoding for each data point. So let's have a look now from the vehicle architecture perspective how a data collection solution may look like. Here we've got a vehicle architecture with two HPCs that are connected through Ethernet with two gateway ECUs. The gateway ECUs are connected through CAN buses, CAN-FD buses, or FlexRay to the remote ECUs. We have a VDP consumer on HPC 1 and have a set of VDP providers that will create VDP network within the vehicle. We may have an additional VDP consumer on the second HPC and a second set of VDP providers that will realize a second VDP network, here shown in green color. Some devices do not participate at data collection and are not dealing with VDP at all. In the last section, I will introduce the VDP CM Remote software component. The VDP Communication Module Remote is a software component of the classic AUTOSAR. It's standardized in AUTOSAR by a software specification in the current release 25-11. The VDP CM Remote interacts with the DCA remotes that are realized as complex device drivers. It configures them and receives the data points. Additionally, the VDP CM Remote interacts with the PDU router to send and receive PDUs for data and control messages. The PDU router communicates with the VDP consumer on the HPC. Optionally, it may handle secure communication using the SecOC component. The VDP CM Remote interacts with the SCBM module to get timestamps and with the NVM module to persist dynamic configuration and data. So far my introduction into VDP. Thank you very much for your participation. Now I would like to hand over to Michael.